Hey guys, Mr. Smith here, and today's video lesson, our third lesson of Unit 2, we're going to be solving polynomial equations using a variety of methods. So we'll do some graphing, we'll do some factoring, and we'll use our factor theorem. So let's get started. We're going to dive right into it. A method of solving polynomial equations that you guys are already exposed to in earlier grades is solving by factoring. Now, in your grade 10 course and grade 11 course, the equations that you would have been required to solve by factoring were quadratic. They were polynomials, but they were quadratic. And you did so by factoring. Well, we can still sometimes factor a polynomial with a degree more than 2 just by applying those techniques we've learned earlier. So, for example, in this particular equation, x cubed minus x squared minus 2x, we can common factor out an x, and we'll be left with x squared minus x minus 2. And that is just a simple trinomial that factors into x minus 2, x plus 1. And then we get being equal to 0. And of course, something you guys learned or emphasized in earlier math courses is that, if the product of one or two or three, or if of like three or more things equals to 0, then of course that means that either like the first thing is 0, the second thing is 0, or the third thing is 0, right? So I'll just say, if a times b times c equals 0, then a equals 0, or b equals 0, or c equals 0. And that's how once you have a factored expression, it's how you get your possible solutions. You ask what makes each factor 0. And of course, for this first bit here, what makes x 0? Well, x equals 0 makes that 0. What makes x minus 2 equal to 0? Well, that's our second solution, x equals 2. And what makes x plus 1 equal to 0? X equals minus 1. So yeah, we can solve this by our old factoring techniques. Let's continue. Another cubic polynomial equation, but we can actually solve with techniques from earlier grades as well. We don't need the factor theorem here. We can actually apply group factoring in this case. Something to look for whenever you have four terms. But if you look at the first pair of terms and the second pair of terms, you can common factor each. So you can take an x squared from that guy, and you're left with 3x plus 1. And you can take out negative 4 from the last pair, and you're also left with 3x plus 1. That binomial factor of 3x plus 1 we can write out front, and then we have x squared minus 4 left over. And we can continue factoring because, of course, x squared minus 4 is the difference of squares. X plus 2, x minus 2 equal to 0. And then you can get your possible solutions by setting each factor to 0. So setting 3x plus 1 equal to 0, you would get negative 1 over 3 when you solve that mini equation. X plus 2 equals 0 gives a solution of minus 2. And x minus 2 equals 0 gives us a solution of positive 2. All right, so the moral of the story here, guys, is, if you're trying to solve a polynomial equation, you don't always have to reach for the factor theorem in division. Sometimes you can use those factoring techniques you've been shown in earlier grades. Now, at this point in time, I'm going to graph the corresponding functions here. And we're just going to make a quick observation between the roots of the equation and the x-intercepts and zeros of the graph. So I'm just going to sorry guys, I'm going to bring up Desmos right now, and let's have a look at those graphs. All right, so here I've got our first. So I've taken that equation, x cubed minus x squared minus 2x equals 0, and I've graphed the corresponding polynomial function, y equals x cubed minus x squared minus 2x. And if you look at the roots, or the x-intercepts of, there we go. If I put in y equals, it actually shows me the zeros. But if you look at the roots of this guy, or the x-intercepts, -1, 0, and 2 are the x-intercepts. And if we compare that with our work, -1, 0, and 2, the roots of this equation correspond to the x-intercepts of the corresponding polynomial function. If we look at the next guy we did, 3x cubed plus x squared minus 12x minus 4 equals 0. When we solved that, we got 3 solutions, -2, +2, and minus the third. And again, you can see that by looking at the corresponding polynomial function. You get x-intercepts at -2, +2, and -0.3 repeated, or -1/3. So please just make a note of that connection. Let's continue. So hopefully, you're convinced roots of the equation correspond to the x-intercepts or zeros of the graph. That is an idea you guys talked about in earlier grades, just making more connections there. All right. Now, not every cubic polynomial or degree or higher degree polynomial can be solved with those factoring techniques from earlier grades. For example, in this one, there's no way to group these 4 terms together to do group factoring, unfortunately. So we will rely on the factor theorem. So let's get going. Now, if you'd like to pause the video and give this a go on your own and just kind of check afterwards, that'd be great. But if you want to kind of follow along, we'll let's do it. So applying the factor theorem, if we think of the possible factors, our value for that final coefficient is -6. The factors of -6 are, ±1, ±2, ±3, ±6. Factors of 2, ±1, ±2. And so if you recall, the factor theorem, or the rational zero theorem, says that any factor of our equation here, any root of our equation, will be of the form b over a, where b is a factor of -6 and a is a factor of 2. So combining all these, we can get a positive or negative 1/1, 2/1, 3/1, or 6/1. So obviously that's plus or -1, plus or -2, plus or -3, plus or -6. But also you could have 1/2, 2/2, 3/2, or 6/2. So you could have 1/2. 2/2 is just 1. We have that case covered. 3/2. And then 6/2 is 3. So we have that covered. And so the things that you would need to try plugging in 1, -1, 2, -2, until you find something that works. So I'm going to bring up Desmos and just give a reminder on how you can do that. So I'll clear off my guys here. And we're going to add a table. And so things we're going to try: 1, -1. Usually start with the easy stuff, 2, -2. And then for our polynomial function was 2, and we'll do x1 cubed plus 3x squared minus 11x minus 6. And those should be x1s. All right. So we can see actually if you plug in 2, you get 0. And so the factor theorem says that x minus 2 is going to be a factor. And so let's use that. Now, I'm going to flip back to our note. So keep in mind, you could actually just hand bomb all of these possible roots in and find the factors and write out the factored form, which is ultimately okay if your goal is just to factor and then do more stuff with that. But we're probably still at the stage where I want to make sure that what's going on in the background. I want to know that you guys can factor a polynomial equation using the factor theorem, using division. So I will. We know that x minus 2 is a root or is a factor. We just showed that. And so now we need to use some division. So you can use synthetic division. You can use long division. It's kind of your call at this point. But I'll show our little prompts here. Minus, times, and remember when we're using synthetic division, we just pop in minus 2. And then we put the leading coefficients of our polynomial, 2, 3, minus 11, minus 6. Excuse me. And yeah, hopefully you guys have got lots of practice doing that. So we're gonna, as we need to use this more and more in lessons, we'll kind of move through them quicker and quicker. So bring down the 2, and then multiply, negative 4. 3 subtract negative 4 is 7. And then multiply, negative 2 times 7, negative 14. When you subtract those guys, you get positive 3. Negative 2 times 3 is negative 6. And we know we did it right because negative 6 subtract negative 6 is 0. So what have we just shown? We've just shown using synthetic division that 2x cubed plus 3x squared minus 11x minus 6 equals 0. We can factor that as x minus 2. And we're left with 2x squared plus 7x plus 3 equals 0. And we're left with the quadratic expression, 2x squared plus 7x plus 3, which we can factor even further. Now, there are a lot of techniques out there for factoring complex trinomials. I'm going to use decomposition. The numbers that add to 7 multiply to 6 are 1 and 6. So I'm going to break up my 7x like so. So I'm just using decomposition here to quickly factor this guy. We ideally are proficient with these factoring methods from grade 10 at this point in our math careers. And just got to, we got to spend our time doing other things instead of all of our brain power on factoring. Keep in mind, guys, though, like ultimately, if factoring is the skill that's holding you back, there are factoring calculators online that at the very least can help you check answers. But yeah, we now have fully factored our polynomial equation. X minus 2, x plus 3, 2x plus 1. And then we can see our 3 solutions we get by setting each of those factors equal to 0. We're going to get x equals 2, box around u. We're going to get x equals minus 3, box around u. And then we'll get x equals negative 1 and then divided by 2. So that's kind of the expectation for you guys. Can you solve a polynomial equation using the factor theorem and division? I know everybody can solve this equation by graphing it in Desmos and seeing what the solutions are. That's not what we're looking for here. I want to be able to see that you can apply the factor theorem, carry out division, and solve a polynomial by factoring. So yeah, there's an example in the books, guys. For when you can't use techniques from grade 10 or 11, we can rely on our new skill, the factor theorem and division. Let's keep going. So I just want to do a quick talk about, sometimes when you factor a polynomial equation as much as you can, sometimes each factor gives you a root. For example, in this last example, we had three factors, x minus 2x plus 3 and 2x plus 1. And each of those factors setting to 0 gave us a real root. That doesn't always happen. So consider the polynomial equation, which has already been factored for us. So we'll do a little deeper dive with this one. So if we look at the first factor and we set x minus 3 equal to 0, we get a solution of x equals 3, which I've just got a very simple graph posted here, consistent with the graph, solution of x equals 3. But yeah, when not every factor gives you a real root. So x squared plus 1 equals 0 gives you x squared equals 1, and x equals negative 1. And you get x equals plus or minus the root of negative 1. And this is not a real number. And so kind of what we've seen here in this particular example is that x minus 3 times x squared plus 1 equals 0 just has one real root. Of x equals 3. And this is consistent with earlier learning, right? We know that this is the corresponding function here is cubic, and we know that a cubic polynomial, it might have 3x intercepts, it might have 2, it might have only 1, but it's guaranteed to have 1. And then this is, as you guys can see here, this is one of those cases. So just because you can factor and just because you have multiple factors doesn't mean you're going to have multiple real roots. In this case, just one real root. So keep that in mind. We're going to do one more. This is just solidifying that idea we talked about earlier. And we just saw in this last example again that the x-intercepts of a graph correspond to the real roots of the related polynomial equation. So we saw that earlier with our first two examples. We just saw that in the previous example. And so we're just getting that down in our note, and hopefully we have that down moving forward. We can always graph the corresponding polynomial function to get an idea of what the real roots are for the related polynomial equation. All right, let's continue. We're going to solve one more problem together. We're going to solve an application problem. And we are going to use a variety of techniques here. So in this question, we've got a block of ice, and we have an expression for the volume of this block of ice. And here, x is the thickness of the block. What we're trying to do is find the thickness of wings that's going to give us a volume of exactly 2,532 centimeters cubed. So in other words, we're solving this polynomial equation, taking the volume, 9x cubed plus 60x squared plus 249x, and we're saying when does that equal to 2,532? Is there one possible thickness? This is a cubic equation. So is this cubic equation like this guy where there was 3 solutions? Or is it like this guy where there's 1? Well, we're going to find out. So first step, so just like you guys learned in your grade 10 course, if you want to solve an equation by factoring, everything needs to be on one side. It needs to be set equal to 0. So we just have to move the 2,532 to the left side of our equation here. So move everything to one side, first step. And remember that we have factoring techniques from grade 10 or 11 that can help us out. And now there is a technique here that's going to make, because these are some pretty high numbers, we can actually common factor to reduce the size of those numbers. And in this case, 3 actually goes into each one of these terms. So why don't we make life easy on ourselves and divide out 3? That's 83x, and that's 844. All right, so we actually, and because 3 is never 0, we've actually reduced this down to still quite a beast of an equation to solve, but more manageable, right? Okay. So now we need to ask ourselves, uh, if we're going to use the factor theorem, which we are here, understanding that technology is great, but we don't want to just rely on technology to do everything. How can we approach this algebraically by hand? We're going to use our rational zero theorem. So you can start by thinking of factors of 844. Now, personally, I don't feel like we could list all the factors up to um, 844. I mean, like if we really wanted to, like 422 is a factor. Like that's a lot. Hopefully, what we're going to see is one of these lower values is going to give us one of a possible factor. Of course, the roots of 3 are a bit easier, or the factors of 3. So some possible roots, ones that are easy to check, you've got 1 over 1, 2 over 1, 4 over 1. So like plus or minus 1, plus or minus 2, even plus or minus 4 would it be that bad to check. But we could also have 1 plus or minus 1 over 3 or 2 over 3. I'm not going to make an exhaustive list of all the possible factors. Hopefully one of those gets us there. And let's bring up Desmos. So let's head here to Desmos, kind of clear off the table and add a new one here. And so let's just try some of our whole number ones and hopefully we get a hit. I'll just try those basic guys. I did this problem a couple weeks ago when I was preparing, but I haven't shot the video yet for it. So I kind of forget which one works out. But let's see. So 9, actually we're doing 3x cubed right now. So 3x cubed, 1 cubed, and plus 20x squared. Make sure to include the 1 so it's using the values in our table. Plus 83x, and then minus 844. Okay. So we didn't get a hit on any of those guys. So we do have other options though. Let's try 4 and see if 4 and negative 4, and hopefully we get a hit there. And just, I mean, 100% guys, I would be using Desmos to do this check. Just checking on a calculator can be, it's fine, but it can be very time consuming. Let's use technology for those things, for those things that, to make things less tedious. But we got a hit here, guys. We got 4. 4 is the root of the equation, so x minus 4 is a factor. Let's head back. And what we just seen is that x minus 4 is a factor. So let's use division and carry on. Do I have, I got some room for this. So let's do some division. So I'll use synthetic division. Just find it a bit quicker. Of course, you can feel free to use long division if you want. So x minus 4 is a factor, and we have our coefficients of, what were they, 3, 20, 83, negative 844. All right, let's just hammer this out. Bring down the 3. Negative 4 times 3, negative 12. And subtract those guys, you get positive 32. Negative 4 times positive 32 is negative 128. And 83 plus 128 is 211. And does this work out? Yes, because we get negative 844 with a remainder of 0. Okay, so where we're at now is we've taken our first equation, and now we're here, right? Now we know that x minus 4 is a factor, and then what's left over is this quadratic, 3x squared plus 32x plus 211 equals 0. All right, now the question is, well, obviously x equals 4 makes that factor equal to 0, right? But what makes this factor equal to 0, right? Are there any such values? So let's actually do a little analysis using the discriminant. So let's just calculate b squared minus 4ac. So that's 32 squared minus 4. A is 3, and C is 211. And I don't know if I can handle that with mental math, guys. 32 squared is 1,024 minus, nope, definitely not. I'm gonna whip out a calculator here. Usually these times is where I discreetly pause my video recording and just do it quickly, but let's do it along with you guys. Minus 12 times 211. You know, it does work out to be a negative. It's almost not important what the value is. Negative 15, negative 1,508. But remember, guys, that this means when the discriminant of a quadratic equation is 0, it means there's no real roots, right? If you were to use the quadratic formula, you'd be trying to root minus 1,508, and you can't do that. And that's okay, right? Remember, we saw in this kind of simpler example that in this example here, we didn't get any real roots from the x squared plus 1 factor. And it's the same thing in our example here. We got a factor of x of x minus 4 and one root of 4. But this other factor that's quadratic, it didn't give us any real roots. So we're actually done. There's only one possible solution to this equation, and it's 4. And x represented the thickness of the wings. The thickness of the wings is 4 centimeters, and that gives you that required volume. Now, just on this slide as well, I've just got a graph of this corresponding function, the function 3x cubed plus 20x squared plus 83x minus 844. And you can see that, yes, indeed, just has the one root, the one x-intercept at x equals 4. So graphing can be a great idea, guys, but we don't want to rely on graphing to just give us our answer right away. I want to know that you can apply these techniques we've been learning. All right. Finally, sometimes you just can't factor. And we're going to go through one example where we can't and just talk about how we can still find the roots. So let's just say we weren't sure if we could factor or not. So we would look at this equation, x cubed minus 3x plus 1, and we would think about what are our possible roots, right? Using our in this case, we just need the integral zero theorem. Possible roots, because the leading coefficient is 1. We just have to ask what are the factors of 1 on the end, the constant term, and our possible roots are plus or minus 1. And because this one, isn't a lot of work, I'll just show my work for this one. So if you were to try those out, p at 1, you get 1 minus 3 plus 1, gives you negative 1. And if you plug in negative 1, you get negative 1 plus 3 plus 1, which equals to 3. Neither one of those is 0. So there's no a way to factor this one. There's no rational roots where it's like an integer or a fraction. But there might be roots. They just might be an irrational number. So let's actually, what we're going to do in this case is we're just going to graph and see what they are from there. So it's not factorable. So in that case, we're going to graph. So let's just head to Desmos and do that. Clear off this stuff here. And so we're graphing, and I would just put y equals, or f of x equals, or whatever. And r is x cubed. Oh, and I should... yeah, no, we're good. Thought I had one more note to make on that, but we're okay. So we're doing x cubed minus 3x and plus 1. And you can see that there are roots, there are x-intercepts, but if we look over them, they're not rational right? And they're not a whole number, or they're not a rational number like a fraction like 2/3 or 5/3 or something. And we can just use technology to see what the roots are. So it looks like we have about negative 1.9, positive 0.3, 1.5, if we're going to one decimal place. So let me just get a rough sketch. This in our notes, and maybe you want to just copy down a rough sketch of this graph too. But what did we see when we graphed it? We got something, just roughly speaking, that looked like that. And we got three x-intercepts that Desmo showed us. And to one decimal place, we got about negative 1.9. This guy was about 0.3, and this guy was about 1.5. Okay, so we try to factor. Hopefully we can, ideally using skills from earlier grades. If we can't factor using those skills, we apply the factor theorem in division. But ultimately, sometimes you just can't factor. And in that case, if there are roots, we need to rely on technology to find those roots for us. Now, I will say there actually is a method to find the roots of a cubic equation. I did not learn that method until I was taking a third year complex analysis course at the University of Waterloo. So that might be a bit down the road for you. Methods do exist, but for us, we're just going to rely on technology if we can't factor. All right, so ideally, you guys at this point can now solve any polynomial equation by factoring, using factoring techniques, or applying the factor theorem that we've been learning about, and division as well, or using technology if worst comes to worst. But I want to stress again, technology is great to check our answers. I do expect you guys to be able to apply factoring techniques, factor theorem, and division of polynomials. In our next lesson, we are going to take a break from factor theorem and solving big equations. And we're going to take a closer look at families of functions. In grade 11, you guys had families of quadratic functions. And we're going to take a lesson and generalize this to all polynomial functions. It's not too bad, a bit of a shorter lesson. In the meantime, got some practice for you guys. Now, I've been mentioning this in my last few lessons, and I'll mention this again. I'm giving you guys a lot of suggested practice. That's a lot of questions, but I don't need you to do all of them. I'm just trying to provide you the resources you need to practice. If you need to practice all of them to master the skill, go ahead. If you do every other one and that's enough for you, that's fine. Maybe one or two from each one is fine for you too if you're working or got sports on that night or something. But practice as much as you need. I suggested maybe doing every other problem, but there's as much as you want to practice, there's work there, and I can get more for you if you need. But that's it for now, guys. Hope you're having a great day. Stay well, and we'll see you soon.